You see here. So if the condition is satisfied, you want to multiply. Actually, this function takes one argument only, but you're using our argument and doing both of them. So for this inner function, you're passing 2. So if you are giving like multiply of, say, if it is an odd, it will do. Say like if I give 3 now, it will do the multiplication and give the result, right? So what is expecting? Function called multiply.multiply2 takes argument, but 2 were given. Actually, it takes only one argument, right? Yeah. So what are the outer one is there? You can just pass to it and do it. Say if I passed. Now you see it worked, right? It is taking 2. You give 3 into 2, you will get like result. So yeah, I need to print it. See now? Oh, you got none. So this is interesting. So it will execute, but you don't get a result because you are not finally returning it. So return, if I say like this, now you see what will happen. I got the result, right? So the return should be there. So but like you understood some way that some way we need to write this kind of hard coding. Means, so if you are doing anything inner logic, so inner functions are working good, but from external, by outside, you cannot call inside. Maybe give some condition, you want to execute something inside based upon the outside logic. That is where some closures comes to picture. Closures. So in inner function, we have an outer function. So based upon the condition, you write a function within it and you write the logic. So closure means giving a relation where you can execute that inner function from outside. But sir, we cannot execute from outside, right? So that is where like here comes. The same example I will take, but instead I will do something what? Instead of returning this number, I will do like this. So means, see what I'm doing here? So I am doing that, removing that. So function. So means not the function result. I am returning the function. See, returning the function, not function result. Not function call result, but function itself I am returning. Now see what will happen. So it will create a closure for you to do. So what is this, sir? What is can be used? So now the result, say like this result is there, right? That I want to assign to something. Say, so m is equal to something. As it is a function, for that you pass anything like, so this function actually you pass it 2, right? Now you have the flexibility. If you pass 2, you can get one result. If you pass 3, you get one more result, like that. If I say here, you see now in this example, what's happening? You got a result. So you earlier hard coded 2 here. Now not only 2, I can do like any number of things here, not just 2, right? I can say like you can pass 3, you can pass 4, you can pass like 5, you can pass like 6. So whatever you pass, that will be multiplied by this value. So initially you gave 3, that 3 will be multiplied with all these things. Don't you think I created a partial function? Similarly, so if I pass like here 10, that 10 will be multiplied with all these things and give you the result. None type value is not callable. Somewhere it had. So yeah. So why it is not doing? So what you did? Only when it is odd, you are giving a result, right? For evens, you are not giving a result. So that's where it is throwing an error. Hey, I don't have in that case. So that's what you need to understand. Hope it's clear. For 2, it's not doing. So for other cases, it's working.
Uday, I have
Yes,
one
please.
question.
Yes, please.
Yeah. So about why we wrote return over multiply 2?
Why we wrote return on multiply 2? So
yeah. So we got the error something, but what is the logic behind that we are writing
I'll give you one more example for you people to understand. So let me give you like an outer function, simple outer function, and let me write a define inner function. So in inner function, you return inner function. Okay, return
Yes.
outer function. Two functions are there, two returns are there. So outer function, if I execute, now what will happen? From outer function, you are having execution to the in thing, right?
Yes.
Now one more thing I will do. So who is calling the inner function? None is calling. So if I call the inner function here, now in this case, what will happen? So inner function will execute, and that result also will execute, right? So from inner, you are calling to the outside. So from outside, you are doing it. But sir, outer inner function is coming, so but outer is not coming. Means instead of returns, if I place a print, then things will be much more easy for you to understand. Yeah. So okay. So inner, if you are making a call, so you need to make a print for you to just see. You see now? So inner function is
Yes.
also executing, outer function is also executing. You are seeing the same. Now the point is, if you want to check, want to create a closure. So whenever you are doing, so what I will do, instead of executing the outer function, so I do one thing. So I do like inner function I am executing. Then in this case, what will happen? So instead of just printing the outer, the inner function is executing. Even in this case also, it's an ordinary inner function. So in the last case, what I am doing this time, this is a closure. Closure where closure means what? Why I'm telling it closure, I will tell you shortly. If I execute right now, what it is saying? So from the main outer function, there is a locals, dot locals and inner. Some kind of relation is established, right? Why it is called as a closure, I will tell you shortly. So from outside, you can call inside function. So inside anyone can call, right? Inside function. From outside, if you call, that's the where it happens. Say result is equal to like this. And from result, if I call, did you see I called the inner function?
Yes.
For everyone, is it clear now?
Yes.
So what is the main point? Inside, if you write any function, anyone can inside if you make a call, you will execute. But from outside, if you want to make a call, so you should not do a return of the inner function, but you should return the inner function. That's what the things. So an example of it is like the decorators. Decorators is a very good example where people will ask you a lot of times. So any function if you have, like from outside, if you are calling the inner function, that is a closure. One example of a closure is the decorators. So in decorators, you will learn like very good things. So means why these decorators came and what is the purpose they are solving, I will tell you. So then we can see. Maybe like I can open a new function and do it. So new script. So C decorators dot ipynb. So decorator is one of the design pattern. Design pattern means what? If there are some problems, to address a problem, we have a particular way of doing the things. So same like for that only. So we have decorators. Let's take first the problem and how I will address, I will tell you shortly. Let's say that I have two functions called as like addition and subtraction. Uh, say like I have two functions called as addition and subtraction. I don't know why it's not working today. Oh, so now they changed this options from, okay, yeah. I need to select the kernel every time. Okay, fine. Say like I have two functions called as addition and subtraction. Now for these two functions, so I will do like two kinds of operations. So whenever I do an operation, how it is working, let's see. Say initially first take the addition itself. I do like two types of results. One is like adding two integers or two strings. In both the cases it works, right? You understood. But for the same addition, if I pass like one of them as a add off, like one of them is 12 and other one is 34 as a string, can I do both like this?
No.
It will fail, right? Similarly, if I go for a division, so division operation of, say, if I given like n1 and n2, so I will return n1 divided by n2. So this is also fine, it will work. Now for this, if I give like three kinds of ways, means I'm asking like, hey, divide 10 by 5, 0 by 10, and 5 by 0. First two cases it will work, but for the third case it will fail. Means here also you wrote one function which is addressing the first two cases, but third case it is failing. Here also you have first two cases it's passing, third case it is failing. Means don't you see that you are having an exception which we need to handle it. To handle these things, what I'll write is that the same addition function I'll write this time with the try exceptions. I wrote the result equal to a plus b. So right, how try except else blocks works. So if the try block is successful without any exception, it will go to the result else. So if there is any exception, it will go to the except block, right? Finally is optional, as you know. Now I will do this and try to execute the same three programs. So these three cases. So what are the three cases I have? So first two cases were like, add with two numbers and so and so. And on top, like I'll take these things, adding a integer and a string. Of course, adding an integer and a string can't be done. Similarly, if I do add of like string and an integer, I have these four use cases. If I execute, did you see the code was not broken, right? So though it didn't handle, it took an exception handling was done, and you got the result. So instead of writing an ordinary add, so you just did the try exception to better handle it. Similarly, for the division also, what we do, instead of just doing a division, I do like a try exception handling. Now, if I execute the same three cases, so now you see in this case, what will happen? It will execute. Means code is executing somehow, and it is not throwing an error. That's what we understood here. But did you see, is there anything common between these two functions? So till now, why we gone to functions first of all? If there is a code which is repeating multiple number of lines, instead of rewriting again and again, you define once and you execute. But what if there is a common code in multiple functions with some part of the code which is common? So don't you see that? So this entire result is same, right? Except this line, the try, except, and else block is entirely common, right? So don't you think? Except this line. So there is something which is common across multiple functions. If you have that kind of scenario, in that case, we can go for a decorator. So how do you write it? So you can write a function called as a exception handling. That's what you're doing here, right? So exception handling. If I write exception handling of, so for a decorator, first thing should be a function. Observe, this is a blind rule you need to remember. So within that you have like a inner function. So this inner function will take the arguments and we need to work. So argument 1 and argument 2. So you need to pass like that. And what are the common logic is there? That common logic you need to take and place within it. So common logic is there. So instead of number 1, number 2, I will do argument 1 and argument 2. I want to do both functions, right? Addition or subtraction. Why I need to do division or something? So what are the function you pass and what are the arguments you pass? I can do with that. So instead of just doing what are the logic, so what are is being done, I wrote like this, function and a call. In the first one, I need to take function, and second one, I need to pass arguments. So will it become a decorator? No. What is the closure means? You need to return the inner function, right? Inner function should be written from the outside. Now it's a closure. So now you understood very clearly how to work with it. So if I execute, so now, and make a call to it, that's where we can understand. After executing, say for making these two understand, I define these functions again in their original format. These basic functions, addition and subtraction, directly I'm defining without try exceptions. Now you see here, there's a 3. For the add, we know 1 and 2, if you give, it will anyhow add. What if I give, 12 and like 34? It will break code, right? You understood this. So fine. Now, so how to handle this problem? I need to pass my function to another function. So exception handling is expecting a function. So I will pass like this. If I pass like this, no, what are you saying? Yeah, sorry. This is very interesting. You pass only the function and the arguments. So for you to better understand, as it is like try exceptions. So this one for you to, big code, right? So you will not digest fastly. Try exception, as example. So print of example. You see now, the first one is a problem which was solved. So how I am doing this thing, you see. First, it is expecting a function, and for the inner function, you need to pass the thing, right? You see now how I will do. Instead of passing like this, you can pass the result like this. You see here, if I do execute now, did you understand? So how I am doing? So outer function, I pass it to it. So again, the result is a function. Now for that thing, I need to pass the arguments. See, what are the arguments you have? 12 as a string, then like 34. If you pass now, it will execute. Observe carefully. So your function, instead of doing in one shot call, you are doing it twice. Did you all understand what I'm trying to say? So I repeat again. So you understood this is a function. So for you to understand, so this is how you did it. In one shot for you to understand better. First you pass your function and give the logic. So first you pass your function and get the result. Say like, result equal to something, and I try to print the result. It's easy. And similarly, if I want to do the same thing for all kinds of 4 cases I have, all the 4 cases. 4 cases means what? First, initially both are like integers. So then like both are strings, and one of them is string, and one of them is integer. You see, in all 4 cases it is executing now. Is it clear what I'm trying to say? You have a function which is passing as an input. So first you need to pass as like this. So similarly, if you want to do the same thing for the division, then do the same thing. So you pass like division means what? You pass 2 arguments and you do the addition, right? So division. So a by b, or what's like, so whatever you want. So similarly here also you can do the same thing, division of. So if you give both good numbers, fine, it will give the result. So here similarly you need to pass, so division, and you can say like, 12 by, sorry, 0 by 12. So that also it will work. And if I say like division of 12 by 0, that also it will work. And 12 division of, and one of them is a string. So I wrote all kinds of 4 cases. So did you see that? Yeah. Okay, 1 second. Yeah. Where am I wrong? What is saying? Oh, say instead of slash I gave like this. Sorry. Yeah. If I give a comma, then it will execute. So did you see what I'm trying to do? So this is what you need to understand. Decorator, it will take a moment for you to understand. So you define the function outside, same like an ordinary function, but the first decorator function will take the function and subsequently inner function. If you define these both, it will not happen. It should be a closure. Only if you return the inner function, then it will be a closure. Okay. Only if you return the inner function, it becomes a closure. Only if it is a closure, then we can use it. But okay, sir, this is good enough. But every time writing this logic like this, don't you think it is something like very complicated? To make the things easy, they created something called a syntactic sugar. Syntactic sugar means, okay, so you know that every time you pass on to the exception handling, so in that case, instead of directly doing, so in what are the function you want to use, in the definition itself you write. In the top with an @ symbol, if you write like this, that's it. You need not do this much logic every time. You can just call your function however you call directly. So instead of calling like this, so how you call directly means, so instead of like that, I can do like result is equal to, so divide of, so what are I have, so 0 comma 12, or like, sorry, 12 comma 34, right? 12 comma 34, and like print result. So don't you think which is better? So do we want to like, result equal to div of, so 0 comma 12 and print of result. So and like, so print of result equal to div of 12 comma 0. Now you will prefer the first way or second way of doing. So in second way, so don't you see both will work in the same way? Which one? Still, even after doing like this also, you can do directly also you can do, or indirectly also you can do. Which one do you prefer? The second one, right? So somewhere we need to write the logic. So either when you're defining or when you're consuming. To make the consumption easy, they did like this. Now the beauty is that we can accept not just one decorator, we can accept like multiple decorators. So let me take one good examples before jumping to multiple decorators. So means more the examples you do, you better you will understand. So let's say I have one function where like, so example, so you have like this. This is one of the real world examples. I have two functions called as addition and subtraction, sorry, multiplication. Did you see that at the starting I have a function print? So at the end also at before the return also I have. In both the functions I have this. So the same thing, how do I implement with the decorators? So how to handle that with decorators? So first I need to create a decorator which can do this common logic. So means define print function. So print function is a decorator I want to create. It will take a function that is an argument. So define inner function. So again, like it will take like argument 1 and argument 2. Good. Okay. So it is doing good. And same like earlier, you took two arguments, right? And you did it. Now, whatever you want to write, pass and return. So inner. So this is a basic structure of any decorator. After creating it, you do whatever logic you want. So what you're doing here, first you're doing a print statement in the starting. So after going inside, you are doing a print statement. So after doing that, what will do? So you try to run the logic, whatever you have. So you are assigning to something like result. Result is equal to, what are the function you have? Argument 1, comma, argument 2, right? So then like after that you have a print statement and finally you are printing it. After that you have print statement and finally you are printing it. Means return. So that result. So don't you see? Both are exactly same, right? Whatever I did. So after I did, so I need not write this much big logic, right? So what is the main purpose of going for decorators? To make your code simple. To make the code simple, so I did like this, and then like I tried to reduce. So instead of doing all of them every time, so I am placing it at the top, as we learned about the syntactic sugar. So at the rate symbol and this one. So I will remove this starting function and this ending function also. I will just do. So similarly, I remove the starting function and ending function and just do like a print function. So don't you see my code became small? So better usage of the code, right? Now, if I make a call to this function, so
Right. Yeah.
yes, please.
Sorry. Yeah. So do we have to return a result over here, addition? Because we mentioned over print function, the basic decorator.
Yes, of course. So
The
here, what are is returning? The same thing this function will return, right? That
right.
only will
But
take care.
here, yeah, here return result we already mentioned. So do
Yes,
we
of
have
course.
to make?
It is a local name. Okay. If you want to make like a result one or something, it's okay. So that is up to
Okay.
you.
Okay.
It's a local variable. Maybe result one if I do like this, fine. That is your local variable. Maybe you can say like res or something.
Okay.
That is their local variables. That's it. Okay.
Thank you.
But here there is one problem. Did you observe that addition is taking 2 arguments and multiplication is taking 3 arguments? So, okay, whatever function comes, you are taking it. But did you see that you took only 2 arguments? Means when you do addition, it will work. For addition, it is working, right? Perfectly, it is working. But when you do multiplication, it is throwing an error. What it is saying? Hey, I will take 3 arguments, but you gave 2 arguments. Okay, I want to handle that one. Then how do I do that? So 3 arguments, if I pass, what will happen? So it will do both. You remember earlier problem when one of them has 2 arguments, one or has 3 arguments. If both need to be handled, how we need to do? The third argument should be a default, right? So, but like if I take a default, say third argument as default as say 1. So whether you take 1 or 0, it depends upon what you do. So if I take like third argument as 0, then what will happen? So I will take here also what are the third argument I defined, argument 3. Okay. Then what will happen? In both the cases, it will execute. So now where the problem came. So when you do addition, it is throwing an error. Means you cannot change the original functions. You need to do your logic. So then how to address this kind of problem? To address that, they came up with a solution. So that is the reason you are not bothered about how many arguments are passed. Whatever you were passed, you pass it as it is. For that, so you need to go for something called as star args and star star kw args. Hope you remember arguments and kw arguments means whether you are given directly or indirectly, you pass it as it is. So whatever you are passed, you pass it to the function. Now you are least bothered about what is coming and how it is coming, right? Did you all understand what I'm trying to say? So this is a solution to it. Now, no matter how many arguments are coming, so again you define another function. So not only this, you define any function, it will execute. So is it clear now how it is working? So if you feel like this is an intermediate, this is a variable which is used only once, you can just do a return. Just to show you like the number of statements were reduced, I used that. Hope it's clear how the print function decorator is working. So maybe so instead of just printing, you want to make it some more better. So means like you can take instead of like just print start, print ending, you can say there is something called as a name. So means if I say function dot name, means it will exactly tell which function and how it is working. So function end. If you see in this example, did you see what happened? So addition function started, addition function before end, multiplication function started, multiplication function before end. So is it clear how it's working? Yes.
Yes. Yes.
Yes. So similarly, there is one more thing called as retry. Sometimes, like, one more use case is like, if I say I have a function called as hello, I want to execute this function so 3 times. Or like, sometimes whenever there is a failure happens, when you hit to some REST API, if there is a failure, you want to retry it. Now, in that case, what should I do? So if I say hello world, I told the same function, I need to execute 3 times. I got 3 times. I want to write a logic for that. So then what I can do, I write a function. So, so retry of like 3 times. If I, so sorry, n if I give, it will execute like for I in, so range of n. So if I do how many times, it will execute that much, right? So if I say hello world of this thing, now after that, if I say retry of 3, it will execute 3 times. If I say retry of 4 times, retry of 5 times, like that. So okay, this is for a simple function, it is okay. So but for a decorators, how we need to execute these things, how we need to do. So means for here you are writing a logic and asking, right, what if on the hello world function itself it should be written? That is where like you need to have a decorator. Means retry again function which will take an argument. So you have a inner function. So the standard thing, star args, star kw args. So within that you write a pass and you return the inner function. This is how you created a structure now. By any decorator, this is the minimum. Outer function name func, inner function name, so arguments and star args, and return the inner. This is the minimum thing. Now you write the decorator. So how you do? Retry. By default, you want to retry something. Say the same hello world, whatever you have written. So if I say like, name was given, you want to execute something. So what are you have? Print of name. You are given something, you want to execute. So if I call like, hello world of say same thing, this time Python. If I execute, it is not showing anything because you didn't write a logic, right? This is a minimum skeleton. So for the minimum skeleton, then now we need to write a logic. So every time, what are the code you were given? So you need to run and do it, right? So for that, what you have func. What are the function call is there? Star args and star kw args. This is what you understood. And the function will execute. If I execute now, what will happen? The function was executed, right? So function is taking the argument and it is executing. Now, so don't you think that I can write the logic to execute like this? So maybe for you to better understand, I'm rewriting again. You see, I want 3 times to execute, right? So for I in, so range of 3, I want to execute. Now you see what will happen? The same function will execute 3 times. So are you understanding what I'm trying to say? So not every time you want to return the end result. So in this particular case, you don't want to return it. You are just printing it, right? So you have use case. And here you are not using the I. You can replace with an underscore. Anytime when you are getting a value and you are not using it from a for loop, you can replace with an underscore. That is a buffer value. So that is how it works. Now, so this is good, sir. But what if I want to pass as an argument and use it? Because you want to retry 3 times. So maybe future, if you want to retry for 5 times, every time you're gonna hard code 5 times. It's not possible, right? Just imagine a real-time example. You are going to a REST API and getting the data. So when you are connecting to the REST API, it is throwing an error. So in dev, you want to retry for less amount of times, or in UAT for another number of times. Maybe like in dev, you want to do for 5 times or 10 times because no one will bother as a developer. So when you go into UAT, less number of times. In production, we should be very careful, right? So based upon that, you want to change it. So then how? You cannot hard code. You need to pass as an argument. Means this retry should take as an argument. Means till now you created a decorator, but you never passed as an input to a decorator, right? But for the first time, you want to pass like 3 and you want to execute. Then it will throw an error. So if you want to use a decorator with some kind of argument, so then this doesn't work for you. So that is where you need to understand. So decorator with a functions. So decorator also can take arguments, you know. So decorator with arguments. How to do with that? So we cannot solve it like this. So to solve it, so for decorator, it will need to pass as a function and do it. So for doing it, so what we can do is that, yeah, so we can take it and pass as an argument. So one more layer we need to add. So same retry, which will take like a one argument. So and like it will go further. Means, yeah, it is taking like so times. How many times, right? Or like count, whatever you have, count I take, and within that you have a inner function. Say inner one, you write inner one. So within that you have like inner two. See, observe how I'm doing inner one and inner two. And similarly, when I'm returning also, after inner two, I need to call the inner two. Then like here, you need to call the inner one. Did you all understand what I'm trying to do? So I wrote like a two inner functions and I asked it. Did you see now it worked? Perfect, right? So the only difference is your decorator is as it is, but if you want to pass as an argument, you need to pass like this. Is it clear? So when you have any arguments, you need to pass like that. So if you want to do for two arguments, I'm just quickly giving for you to understand. So the same thing you write, but for like a two arguments. Maybe like why you were trying also, if you want to print or something, you know. So div environment or something if you want to say. So you can do that. How we can do? So maybe like count and you want to pass the environment. So div or like UAT if you are doing, right. So if I say like environment, okay. So if you see here, environment and count. Say here this time environment equal to say div. I want to do 3 times. Okay. So I just want to give with names. So for better understanding. So you see now it is executing. Maybe like here you can write like div environment. So you see now what happens. Div environment you got like this. Now the same thing execute multiple times. So with a UAT environment. Yes, please.
Yeah, sure. So here we pass retry 3, right?
Yeah. Yes. Yes.
So why it comes for 5, like 5 times?
Yeah. Sorry. So that's a big problem, right? So here we didn't address it. Whatever you wrote the count. So we need to change inside instead of 5. So that's what we didn't say. Yeah, good for noticing it. So if you replace that, so here also you didn't change. If you change to count, now you see here it will execute. So this time also if you execute, it will execute like that. So one argument, two argument, like that, any number of arguments you can pass, even for a decorators also. Is it clear how we are defining? So if your decorator is also taking any arguments, you can do it. So similarly, like if there are multiple decorators, if you want to pass, then also like you can create and you can execute, and decorators will execute from the bottoms up approach. So this is an example for that. So decorator 1 function, decorator 2, decorator 3. If you are executing,